Hi everyone, welcome to ACE Preparation League. This is Ramesh. Now we are going to start the second session on the subject called measurements. Yesterday we have seen first session, few questions related to the entire measurement we have seen. Now let us continue the second session, that is measurements. Now let us start the first question here. In the yesterday's session we have seen error analysis questions and PMMs related questions we have seen. Now we are going to take the question continuously, MI instrument and next one potentiometer, bridges, etc. All topics we are going to cover. Now the question here is the inductance of a moving iron ammeter. Now this is a question related to MI instrument. This is a question related to MI instrument, but this is the question related to little bit more mathematics. Sometimes 2 marks related chance may be there. That's why let us have this also. With a full scale deflection of 90 degrees. What is the value of full scale deflection? 90. So theta equal to 90 degrees. For a current of 1.5 ampere, right? If you give 1.5 ampere, the full scale deflection will be 90 degrees. Okay? Given by the inductance of the moving iron instrument is given, right? So and so 240 theta minus 4 theta square minus theta cube microhenry is given. Now, where theta is deflection in radians, very important point. Whenever we are having the theta in the inductance, either self-inductance or mutual inductance, anything in other instrument, you need to observe where what is the nature of the theta, that is it is given as radians. Of course, from the 0 means from 0 to full scale only he has mentioned. Now, estimate the angular deflection of the pointer for a current of 1 ampere. What is that? If you are giving 1 ampere of current, what will be the angular deflection? Be clear guys, very important point here. Generally in the question, inductance will not be given if they want to ask it for 1 mark model. If it is a 1 mark question, they don't give this inductance. Simply, sir, 90 degrees, 1.5 amperes, 1 ampere, how much? Directly we can take. What is the relation? MI instrument, theta is proportional to I square. Every one of you know that. Based on the theta 2 by theta 1 equal to I2 square by I1 square we can take. But here inductance is given. It is varying with respect to the corresponding condition. That's why it is little bit involved with mathematics here. What is it? Let us see. And here I am giving idea purpose, values also I am giving just for clarity purpose. Right now, here first one, let us write the given data. Right. Here, full scale deflection, what is it? Simply 1.5 amperes is given, right? It is giving the 90 degrees deflection. Okay. Now, self-inductance of the coil or self-inductance of the moving instrument coil, 200 plus 40 theta, 200 plus 40 theta minus 4 theta square minus 4 theta square minus theta cube. So many microhenries is given. Okay. You need to follow one step. If L is given, find out the dl by d theta and keep it with you. Then that will be more better. Means differentiate this and keep the value with you. It will be useful in the coming steps. What is that? So dl by d theta. dl by d theta. It is a constant 0. 40 theta means 40 and minus 4 theta square. Theta square means 2 theta. Therefore, what is that? 8 theta and here minus 3 theta square. Of course, don't forget this microhenry per radian. Why? dl by d theta, inductance is Henry. What is it? Unit of theta is radians. No. What is the other data he has given? No. This entire thing is given. Estimate the angular deflection of the pointer for a current of 1 ampere. If you give 1 ampere, how much deflection? So therefore, 1 ampere of current is given. How much is the theta value? But be clear, don't neglect this inductance when they give the data of inductance in the question. Otherwise, all I told you know, I1, theta 1, I2, theta 2, directly you can proceed, but this is involved with inductance given in the data, so you need to go for it. What is that? Simply, first step I am taking, sir, what is the angle of deflection theta formula in moving iron instrument? Half I square, right, by Kc dl by d theta, dl by d theta. The point here is, if you observe this entire thing, which values are given? Which values are given? Theta is given. What is that? Yes, 90 degrees. For a current of 1.5. So theta substitute 90 degrees. Convert that into radians. I will be 1.5 square and dl by d theta is also available over there. Therefore, whatever the unknown parameter is there in this equation, get the value of that unknown Kc value. Therefore, what we can write here? Kc is equal to, if the Kc is brought here, what is that? Half I square by theta dl by d theta. Procedure is simple, concept is simple, but you need to concentrate on the calculation part. Clear? Now the point here is, sir, in this, substitute the values. Half, what is I square? The I square is 1.5 square. 1.5 square by theta. Here you need to concentrate more. The theta will be in, or the theta should be in radians. But what he has given? Degrees. So simply 90 into pi by 180 is the radian form. Why, sir? dl by d theta is given in radians notation. So therefore, you need to convert this into correspondingly into radians. Clear? Right. Into, what is dl by d theta? The dl by d theta value is 40 minus 8 theta minus 3 theta square. 40 minus 8 theta minus 3 theta square. But sir, what should be the value theta? The theta value should be equal to which one? 90 into pi by 180, pi by 2. You need to substitute the values over here. If you substitute the values, you are going to have the corresponding Kc value. Now calculate and verify. I am going to give you the value directly, but you calculate and verify the value. What is that? If you simplify this, you will be getting, I gave you for idea purpose, Kc equal to 14.348 Newton meter per radian will be there. The Kc value is right here. The Kc value will be 14.348. Here 14.348 Newton meter per radian will be there. So this is the value of Kc we have calculated. Clear, guys? Now, sir, this calculation is, yes, in-depth mathematics calculation only, but practice purpose, these type of questions also may be possible. 2 marks model, that's why I'm taking, so no need to worry. Right? Now, here, after getting this entire Kc value, again same thing. What is that? Therefore, again, theta is equal to half I square by Kc dl by d theta. Now what he is asking, guys, here, if you are giving the 1 ampere of current, what should be the angular deflection? Means we need to find out the angular deflection theta with the help of current of 1 ampere. So therefore, you need to focus here. Sir, half into current is 1 square by Kc value, already we have got it. What is Kc? 14.348. Here, 14.348, right? Into dl by d theta. Anyway, you know that. What is that? 40 minus 8 theta minus 3 theta square. So therefore, 40 minus 8 theta minus 3 theta square. Right? If you substitute all these things, if you substitute all these values, you are going to have the theta value in terms of radians, convert that radians into degrees over, right? Kindly verify. Kindly give me the value. Anyone? Right, 14.34 to Rahul, you have given. Very good, very good. Right. Now, any other theta value? No worries. I have all the values, but I'm making you to practice. Sir, you will be getting 1.00712 radian. Kindly verify. You will get 1.00712 radian will be there. This is correct answer. And if you want to convert this into degrees, yes, you can convert into degrees in the options, in the examination. If multiple choice question is given, radians or degrees they may be giving. Or if it is a numerical answer type also, they will be asking the corresponding value. They will be asking the corresponding value. So therefore, automatically, you will be having the, what is it? Radians or degrees. So you need to convert this. 57.7 degrees. 57.7 degrees. This is what the final answer. Right. Why I have taken this question, to revise the concept and to have simple mathematical, what is it? Strengthening, to increase the mathematical practice. Yes, this is what I have taken. Clear? Right. Now let us take one more question. Current in the primary winding of CT depends on, right? This is the question related to, instrument transformer, that is current transformer. Now the question is, in the gate examination, 2 marks questions, 1 mark questions, and a few questions may be directly based on the concept also there. That's why it is purely conceptual question. What is that? Current in the primary winding of CT depends on. For this question, there are a lot of chances to give the wrong answer. That's why be careful with the options. Burden in the secondary winding of the transformer, nothing but the primary current of CT depends on the burden? Definitely no. Second one, load connected to the system in which the CT is being used for measurement. Sir, where you are using the CT, right? Wherever you want to measure the current, there we are using the CT. So therefore, whatever the circuit we are using, right, for measurement purposes, at that condition, whatever the load current is there, that will be giving the primary current of CT. That is correct. But both burden of the secondary and load connected to the system, no, burden is not at all playing the role, and none of the above. So what is the appropriate answer, conceptual point here? This one. Right. But don't worry, if the conceptual question is there, just by explaining the point, just by noting the point, not like that. I will be explaining the concept also. Be clear. What is the meaning of this is, suppose I am taking one line here. I am taking one line. This is the load. Okay. Now, one line is like this, high capacity line. And everyone knows that the current transformer or potential nothing but instrument transformers are used for measurement of high values of voltage and currents. Everyone knows. Like that, large value of voltage, which we don't know, large value of current will be there. Large value of voltage or large value of current, for example, is there. Now, in order to measure this current, what we use, guys? We are going to use current transformer like this. Of course, everyone knows current transformer is step-up transformer. Yes, this is CT. Current transformer is step-up transformer. We have connected the CT. Now tell me, sir, primary current of CT is based on which current? Is based on load current. Whatever the load is drawing the current, that current only flowing through the primary winding of CT. That's why, check it, load connected to the system in which the CT is being used for measurement. Yes, load connected to the system in which CT is being connected for measurement. So therefore, what is the answer? Load current, or we can say load will decide. But sir, what can be the confusion? Many people are asking the doubt like, sir, in this is I1, this is I2. What is the calculation, guys? The calculation will be N2, number of turns, N2 by N1 is equal to I1 by I2. This is a general turns ratio. Okay, N2 by N1 and correspondingly current relation. From this, N2 and N1 are number of turns will be given in the nameplate details. I2 will be shown by the ammeter, which is our unknown. I1, therefore, we are going to calculate I1 like, what is that? N2 by N1 into I2. By taking this concept, many people are getting confused like, sir, I1 will be given by the secondary winding of the CT. No, what is the point, you are calculating the I1, with the help of I2. But what is the question? The I1 primary current or current through the primary winding is decided by, means this I1 will be decided by the load. But how much value is there, that we are going to calculate with the help of I2. That's why try to understand the question. He is not asking that current in the primary winding of CT is calculated by, no, not he is asking. What is it? Here, current in the primary winding of CT depends on, so therefore, the current flowing through the primary winding depends on which one? Load current. That's why the primary winding current will be decided by the load. Whatever the load required value is there, that only flowing through the CT primary. That's why be careful with the selection of this. Why I'm stressing this, numerical question means many people are fond of substituting the values in the formula, but conceptual means automatically, definitely people are getting confused. So that's why be clear with this notation. And here, right, Aravind Reddy, sir, electronic measurements also will you take? Yes, I am going to cover all total measurements and line current, Aravind Reddy, that is load current we can say. Secondary current depends on primary current, not like that here. Secondary current, right, will be reduced from the corresponding primary, we should say. Okay, right, let us take one more question. Right. In a series type ohm meter, this is measurement of resistance topic, right? In a series type ohm meter, as shown in figure, I'll give that. The meter has the 50 ohm resistance. The meter has 50 ohm resistance and full scale current of 1 milli. Very, very, very important point is the meter has resistance and full scale capacity is 1 milliampere. Now, this is the circuit given. So this is nothing but ohm meter. That to which type of ohm meter? Series ohm meter. Series ohm meter. And here in this series ohm meter, I hope everyone able to recollect this one. So the point here is, sir, this is the connection we are connecting the corresponding Rx value. And wherever we are using the device, that is meter, this meter value given as 50 ohm. So therefore, meter resistance, what is that? The figure, meter has correspondingly 50 ohm resistance is given. Okay. And what is the full scale value of this meter? 1 milliampere. Only data what he has given, I have taken. Now what he is asking, be clear. Be clear. Sir, the total resistance in ohms of the ohm meter circuit is 2000. This is the starting step playing the crucial role. This is total resistance. How much value? 2000 ohm. Total resistance 2000 ohm. And the battery voltage is 6 volt. Nothing but total voltage is given, total resistance is given. Sir, can we calculate total current? Yes, total voltage by total resistance. This is the key point in this question. Okay, so therefore supply voltage is 6. Okay. The value of potential divider resistance. He is asking potential divider resistance. Okay, but that too at which condition? Corresponding to full scale of the meter. Corresponding to full scale of the meter. That's what he is asking. So be clear, be clear. Sir, in this, here. Sir, what is the circuit? This is a circuit given. He is asking this R2 value. Potential divider resistance means what? Yes, this only, because as it is keep on getting varied, the voltage division will be taking place. Yes, potential divider resistance we have to calculate. But key point here is potential divider resistance at which condition? Corresponding to full scale of the meter. That is what very important. Now let us redraw the diagram in the solution for more clarity. Here meter is being taken, right? And here one resistance, directly I am writing like this, resistance, and here one more resistance is there, and then source, common series ohm meter only, one more resistance, and here some voltage source here, and simply Rx value. Let me take this is R1, this is R2 something, and battery voltage is given as 6 volt. Battery voltage is given as 6 volt. And this meter resistance is given as 50 ohm, and its full scale current is given as how much? Full scale value is 1 milliampere. So therefore, the full scale value of current is 1 milliampere. Now, very simple point. Yes, kindly concentrate here. One hint he has given, total resistance and total voltage. Yes, total voltage is given. Why I am stressing this point, many of the people are getting confused like, sir, Rx is not there. If Rx is unknown, how can we proceed? In that way, the people are getting confused. Be clear. Simply, total resistance of the entire ohm meter circuit, total resistance is given as 2000 ohm. So therefore, total resistance is 2000 ohm. Total voltage is VT I am writing. Total voltage is 6. Can't we calculate total current? Yes. So therefore, in the corresponding circuit, total voltage and total resistance is given. We can calculate total current. Assume that the current like this or direction, no need to worry. This is I total. Therefore, what is the total current value? I total is equal to, what is that? V total 6 by 2000 ohm. If it is 6 by 2000, 6 by 2 means 3 milliampere. So what you have calculated? Total current in the circuit is 3 milli. But be careful. So total current is coming over here. At this point, current will be divided. Of course, compulsory. Current will be divided. But sir, how much current is flowing through this? How much current will be flowing through this? That will be depending on generally this resistance value, right? Sir, this resistance only unknown. How can we get it? Means he has mentioned clearly the value of potential divider resistance corresponding to full scale of the meter. Therefore, here through this, ISD is equal to, IFSD is equal to how much value? 1 milliampere. That's what the point. Sir, under condition means 1 milli is going like this, 3 milli is coming over here, automatically current through R2 will be 2 milli. So therefore, here current through, right? What is that? This is R2 I am taking, for example, right? He has given R2 only. So therefore, R2 I am taking current through R2, right? Under full scale value of ammeter. What is that? Simply current through R2, IR2 equal to 3 milliampere minus 1 milliampere is equal to 2 milliampere over. Now, very important. Sir, through this path, how much current is flowing? 2 milli. As these two are in parallel, voltage will be same. Therefore, current into resistance, we can write. So therefore, by the voltage is common in parallel like that, simply what we can write? Now we can write, what is that? 1 milliampere into 50 ohm is equal to, right? Now 2 milliampere into resistance R2. Simple. Now, therefore, R2 is equal to how much value? 25 ohm. Clear? Right. See, the moment the word ohm meter is seen, many people are not touching that point. Ohm meter concept we know, we don't know the numerical. That's why people are not touching this. But in this, do we have any in-depth mathematics or in-depth logic at all? No. Simply only one hint. That too, hint is given. We need to find out potential divider resistance value R2 under meter full scale condition. If you hold that point, the thing will be very simple. That's what the point. Clear? This is the value, and already I gave you. Yes, 25 ohm. We have got it. Clear? Right. Now let us take one more question. The EMF of a standard cell used for standardization. This is a topic related to potentiometer. I am taking one question, universal question related to the potentiometer. If you solve this question, all varieties of questions will be solved. All varieties of problems will be done in the potentiometer. Right now, standardization voltage is how much? 1.0186 volt. If the balance is achieved at a length of 55 centimeter, what does it mean? For 55 centimeter, this is the voltage he has given. Okay. Now, here, he is asking almost, I am taking 4 questions, A, B, C, D. But if you understand the first part, other things will be very much clear. No need to worry. See here. The EMF of the cell which balances at 70 centimeter. Very simple here. Sir, 55 centimeter, what is the voltage for balancing? 1.0186. At what value he is asking? 70 centimeter. How much? Very simple. For 50 centimeter, 1.0186. 70 centimeter, how much? You will get the first value directly. Clear? Right, I am writing that. One by one question I will read out later. 4 questions I am combining to cover the entire potentiometer topic. What is that? First one, A. Right? Now the point is, for 50 centimeter, for balancing, how much voltage? 1.018 volt. Check it here. 1.018 or 186, no problem. 55. The given value is 55. Right? 1.0186. Sir, for 70 centimeter, how much value? Very simple, direct answer. 70 by 50 into 1.0186 volt. Calculate this. You will be getting the value as approximately 1.29 something. 1.29 something. Clear? Right? Now, second one. This is a direct part, but second one, here 1.29 something approximately you can calculate. Now, the current flowing through a standard resistance of 2 ohm. The current flowing through a standard resistance of 2 ohm, if the potential difference across it balances at 60 centimeter. Right? If the potential difference of balancing it 60 centimeter means, sir, across the 60 centimeter, what is the voltage we need to calculate? After getting that voltage by resistance, automatically current will be there. That's it. In this direct voltage calculation, now 55 centimeter, this is the value. Sir, 60 centimeter, how much? Automatically you will get. After that, current through this resistor is V by R. Okay, now let us take that. Right, second part. Sir, 55 centimeter, how much is given, guys? 1.0186 volt. Okay, now for 60 centimeter he is asking. 60 centimeter, why? But you need to understand the point. Sir, for 60 centimeter, he wants to balance the circuit. Means we need to calculate first voltage. After that voltage only, he is asking the current. So therefore, What is the value now? 60 by 55, 60 by 55 into 1.0186 volt. If you simplify this, you will be getting approximately 1.11. I gave the values, just verify. Yeah, 1.112 volts will be there approximately. Right? We will be having 1.112 volt. Right? Now, after this, what is the current? Therefore, current through 2 ohm resistance. What is the voltage across that? What is it? This one. What is the resistance? 2 ohm only. Therefore, 1.112 volt by how much? 2. You will get approximately 0.55 amperes. Approximate value I am giving. Yes, this is what? One answer what he is asking. Clear? Right. Now, third one. You verify, I gave the value as 0.5556, no problem. Approximate value. Clear? Right. Now, the third one is the percentage error. One more step extra here. The percentage error in a voltmeter reading 1.4 volt when balance is obtained at 80 centimeter. Very important. Topic to topic I am combining potentiometer and error analysis. Both are being combined and frame this question. Be clear. Sir, what value he observed? He observed 1.4 volt. At which centimeter? 80 centimeter. Then what is the corresponding percentage error? First of all, do we get percentage error or not? That we have to see first. Okay. Now, at which centimeter he wants to balance the system? For which centimeter? He wants to balance the system at 80 centimeter. Okay. Now, let us have the mathematics first. Right. Sir, C, part C. What is that? 55 centimeter has 1.0186 volt. That is a given data, standard data. But in this part C, which value or at which value he wants to have the balancing point? He wants to have the balancing point at 80 centimeter. 80 centimeter. Let us find out this first. Sir, 80 by 55 into 1.0186 volt. Sir, if you simplify this, right? If you simplify this, suppose if you are getting same voltage of 1.4 for example, right? He observed 1.4. If we are getting same 1.4, then we can say, yes, actual value 1.4, measured value 1.4, therefore error will be 0. Suppose if you are not getting this 1.4, automatically error will be there or not? Let us see now. Sir, here, right? If you simplify this, you will be getting 1.4816. 1.8416. But here, very important, crucial point is, this is the actual value across which centimeter? 80 centimeter. Okay. But how much value he observed? He observed as just 1.4. He observed as just 1.4. But actual value is 1.48. So definitely deviation is there or not? Obviously, therefore error will be there. Okay. Now, what we can write here? Therefore, sir, true value of voltage at 80 centimeter is 1.4816 volt. Okay. And sir, what is the measured value at 80 centimeter he has given? Just 1.4 volts. I am very much specific about this, people are reversing this terminology. If you reverse this terminology, you are going to get minus instead of plus, plus instead of minus. But our error analysis, and I told you, error can be either negative or positive. So be careful regarding that. Now, therefore, sir, percentage error is equal to, what is that? AM, nothing but VM measured minus 80 by 80 into 100. Now substitute here. Sir, AM 1.4 is less than 1.4816 by 1.4816 into 100. The first observation is, are you going to get negative value or positive value? Tell me. Of course negative value. Yes, negative. Now calculate and verify with my value. I am giving the values directly because to avoid the calculation time. You calculate and verify with my values, right? What is that? If you are simplifying this, you are going to have, already gave you, minus 5.5% approximately. So therefore, I can write here minus 5.5%. So this is one answer. That is C-bit answer. Clear? Right. Now, sir, let us go to fourth part. Let us go to fourth part of the system. What is that? Here. The percentage error. Again, he is asking percentage error, but other formation. The percentage error in ammeter reading, right? 0.35 amperes when balance is obtained at 45 centimeter. 45 centimeter with the potential difference across 2.5 ohm resistor in the ammeter circuit. In the ammeter circuit. What he is asking? The percentage error in the ammeter reading. Nothing but in the earlier question, related to the voltage, he asked the error. But now, related to the current, he is asking the error. Therefore, what is the ammeter reading he observed? Means current measured, he observed is 0.35 amperes. Current measured, he observed is 0.35 amperes. When balance is obtained at 45 centimeter, okay, at which centimeter? 45 centimeter. And with the potential difference across, resistance is given as 25 ohm. Okay, now, length, he wants to balance. What is that? 45 centimeter. So that is what playing the role. Now let us find out for 45 centimeter, how much voltage will be there. Here, part D. What is the logic here? 55 centimeter. 55 centimeter gives, what is it? 1.0186 volt. 1.0186 volt. At which centimeter? He is asking at 45 centimeter. Okay. Now, very simple. 45 by 55 into 1.0186 volt. Sir, 55 this much, 40 will be less than that only. Approximately you are getting 0.8 something. You will be getting the value as 0.8 some volt. Okay. But be careful guys. He is not asking the voltage. He is asking which one? Be clear with the question. Here. The percentage error in ammeter reading of 0.35 amperes means he is measuring the current as 0.35 amperes. We need to find out the true value of current. If both are equal, error will be 0. Both are not equal, error will be non-zero. So therefore, what is that? Around 0.35 means around 0.35 we are going to get. Therefore, deviation will be there. Error will be there definitely. So therefore, what is the logic here? You will be getting 334 volt. Now, what is 0.5 ohm he has given? So therefore, sir, here current, right, through the 2.5 ohm resistance is, what is the voltage? 0.8334. 0.8334 by 2.5. 2.5, right? If you simplify this, you will be getting 0.33 something will be there. 0.33 something. Okay, approximately. You calculate and verify. But my question is, what is the observed current? What is the measured current? That also I am writing. Sir, current through 2.5 ohm. What is that? Measured value. But this is true value. So measured value is given as 0.35 amperes. Sir, what is the measured value of current? 0.35. What is the actual value of current? 0.33 something. Kindly verify this. 0.35 is given. 0.35 is given as the ammeter reading, but we are going to get, already gave the value 0.33, so 0.33336 will be there. Okay, next, like this will be there. Okay, now sir, these two are not same. If these two are not same, automatically what we can say, error will be there. That is, therefore percentage error is equal to AM minus 80 by 80 into 100. AM 0.35. AM is 0.35 minus 80 is 0.333 some number. What is the value? 80 is 0.33336 into 100. You are going to get approximately 5% or 4.9, but be careful. Here, large minus small, so plus only. You are going to get 4.9 approximately. Nothing but, with this entire potentiometer question, what I have taken? Balancing at different lengths. After getting the balance at different lengths, we are going to calculate, or we have calculated, current to through some resistor, voltage across resistor, etc., etc., etc. That is what the point. That's why I told you. If you understand this question, right, with this, all varieties of potentiometer balancing conditions will be clear. That's why I told you this is very, very lengthy model. But sir, as it is, question may not be there. Out of these A, B, C, D questions, they may be asking any two, they may be asking any one as a 1 mark question, or any two as a 2 marks question. Chances. That's why universally all the models I have considered only in one question. Clear? Right. Next one. Let us take one more question. Electrodynamometer type wattmeter. This is the question related to wattmeter concept with measurement of power notation. Okay. Has a current coil with a resistance of 0.1 ohm. So what is the current coil resistance? The current coil resistance is 0.1 ohm, right? And pressure coil with a resistance of 6.5 kilo ohm. 6.5 kilo ohm. Calculate the percentage errors while the meter is connected as. While the meter is connected as means, sir, before going to the question, just for 30 seconds of time, let us revise the topic. Sir, electrodynamometer type wattmeter is there. How many ways you can connect for measurement of power? 2 ways. One is potential coil towards the load side, or potential coil towards the supply side. That is generally called as MC short connection, LC short connection. Yes, that only he has given. Check it. Here, current coil to the load side, and second one is pressure coil to the load side. So one time current coil, one time pressure coil to the load side. Means MC short as well as LC short. Both he has covered. What is the data given? The load is specified as 12 amperes at 250 volt with a unity power factor. Total data is given. What is it? 12 ampere, 250 volt and unity power factor. This is the total data. But be clear, this question is very simple. I can say straight away question. But why we have taken this question for practice purpose as an expected question? You know, these type of questions are also more popular. But the problem with this question is, you must be able to recollect the formula. What is that? What is it? When the current coil is connected to the load side, means automatically, is it MC short or LC short? MC short connection. Potential coil is connected to load side means LC short connection. That's what the point. So therefore, be clear, right? Here, let us verify the answers later. Here, first point I am taking, that is first one, right? Here, current coil CC is on load side. Current coil CC is on load side. Okay, sir, what will be there if it is on load side? What will be the procedure? Sir, percentage error is equal to, do you remember the formula? Percentage error when current coil is on load side. So automatically, what is the formula? IL square RCC by IL square RCC by, what is the value? VL IL, of course, into cos phi into 100. What is that? This is the error magnitude. This is the true power into 100. You need to recollect this formula at any cost. You need to recollect this formula at any cost. So be clear. Sir, substitute the values. IL, what is IL? He has given 12 amperes. Okay? And RCC, current coil resistance, is 0.1. So therefore, what is that? 12 square into current coil resistance is 0.1 by, what is VL? 250 volt. Load voltage is 250 into load current is 12 into power factor is 1, of course, into 100. Direct answer. But all I told you, the question is very simple, but people are reversing the formula. First formula to second one, second formula to first one they are doing. So that's why be clear with this corresponding value. What is that? If you simplify this, you will be getting approximately 0.48%. Kindly give me the values like yesterday. Right? Yesterday you gave the values properly. Yes, yes. People are giving. Kindly go ahead. Kindly go ahead. Right. Now here, yes, 0.48%. What is it? This is the question in the, what is it? First case, current coil is on the load side. Okay. Now, what is second question? Pressure coil to the load side. Pressure coil is on the load side. So if the pressure coil is on the load side, which short? LC short connection. So therefore, second part is potential coil is on load side. If the potential, nothing but if the pressure coil is on load side, what can be the formula? Right? Everyone, kindly I am requesting to recollect the formula, because direct question it is. But only problem with recollecting the formula. What is that? Percentage error is equal to, that is what? VL square by RPC by VL IL into cos phi into 100. That's it. All values are given. Now the point here is VL. What is VL? He has given VL as 250 and pressure coil resistance is 6.5 kilo. So therefore, here 250 square by RPC 6.5 kilo, 6.5 into 10 cube by, what is VL? 250 into, what is IL? IL is 12 ampere into power factor is 100. Clear? So this is, if you simplify this, you are going to get the error directly. You are going to get approximately 0.32%. Kindly verify your values with my values. Kindly verify your values with my values. Come on guys. This is 0.48 and this is 0.32. But the people are getting confused like, sir, this question is very simple. No? Yes, I am coming to that only. In the options, they may be giving like this. They may be giving, suppose, first option, 3.2%, comma, 4.8%. Right? Sorry. 0.32%. They may be giving options like this. 0.32%, comma, 0.48%. Option may be like this. Second option, 0.48%, comma, 0.32%. Sir, in both options, same number is there. But sir, which is the first question answer? Which is the second question answer? That is what the main headache for many people. That's why you must be able to recollect the formula compulsory. That is what? Current coil is on load side. Automatically IL square RCC by corresponding power. And potential coil is on load side. VL square by RPC by correspondingly total power. Therefore, what can be the answer? Second option is the answer, because first current coil load side, second potential coil load side he has asked. That is what the actual point. Clear everyone? That's why this question is very, very, very popular, right? By giving two things and options also, two answers will be there. What is that? X comma y, y comma x, which is correct, means obviously this is correct value. Clear? Right. Now let us take one more question. Right. The meter constant of a, sir, this is a question related to energy meter. Slowly I am touching all the topics, Right, Chitti Lahita Sri Reddy, yes, 0.32, got it correct? Very good, very good. Right. Now let us see. The meter constant of a 220 volt 5 ampere energy meter is 2000 revolutions per kWh. Everyone must be clear with the meter constant what he has given. That itself is playing the role. Everyone knows the concept. That is, meter constant is revolutions per kWh. This is given. But what is the voltage and current rated values? 220 and 5 amperes. But the meter is tested at half load. Very, very, very crucial point. This I can say key point in this. That is what? The meter is tested at half load at rated voltage and unity power factor. Therefore, testing is done. Testing is done at half of the load, but voltage is rated, power factor is unity. Right? The meter is found to make how many revolutions? 34 revolutions in 116 seconds, 116 seconds. Means operation time is this much. Determine the meter error at half load. Determine the meter error at half load. In this, I am going to clearly indicate what mistakes we do generally. Then, if you see the options, suppose if the multiple choice question model is there, whatever the wrong answer we get, mostly that answer will be there in the options. Because it is a negative marking paper, yes, most of the cases chance is there. Okay, what is the given data? Let us write first. The given data is here voltage is 230 volt, current is 5 amperes, right? Yes, so 220 volt. 220 volt and 5 ampere. Constant is how much? 2000 revolutions per kWh. 2000 revolutions per kWh. And the meter is tested at half load. Very, very important. Half load. So therefore, I am writing this as a note. Half load, rated voltage, half load, rated voltage at UPF. At UPF, right? How many number of revolutions they observed, right? When it is tested at this, the meter is found to make 34 revolutions in 116 seconds. So therefore, 34 revolutions in 116 seconds. 116 seconds. So 34 revolutions they observed. And they are asking that. They are asking, find percentage error. The first mistake the people generally does is percentage error, only the thing that just percentage error. But he is asking percentage error at which load? Half load. If you are missing this word, definitely 100% chance is there to get the wrong answer. So that's why you need to be very much careful with this point. Half a load, percentage error, half load, you need to be very much careful. What is that? Be clear. Sir, percentage error formula is how much? AM minus AT by AT. Generally, let us find out AT first, right? What is that? First step, energy true. What is energy true formula? Energy true formula will be, what is that? Voltage true, current to true, power factor 2. V into I into cos phi. Power into true time. What is the time he has given? 116 seconds of operation. So therefore, voltage is 220, current is 5, power factor is 1. But, sir, V into I into cos phi, always in terms of watts only. V into I into cos phi in terms of watts. Therefore, by I am making 1000 means kilowatts. Okay? Into. What is the time? 116 seconds. But I am converting that into 3600 means what is that? Simply hours. So totally you will be getting, what is that? Kilowatt hour. Okay? Sir, going to get some value in terms of kilowatt hour. Leave it, something. I'll come to that. What is your mistake? Now, energy measured. How do you calculate energy measured? Everyone knows the concept. Here, based on the meter constant only, we are going to determine the corresponding energy. What is the logic here? Sir, if the meter makes 2000 revolutions, it has to show 1 kilowatt hour. That is what the rating. But how many revolutions we observed in this condition? 34. So simply, what we can write here? Sir, 2000 revolutions, right, gives what is that? 1 kilowatt hour. 2000 revolution gives 1 kilowatt hour. But how many revolutions are there? 34 revolutions gives dash. Very simple. Sir, 34 by 2000. 34 by 2000 means simply 17,000 and 1 kilo will be cancelled. So therefore, 17 watt hours. Very simple. Very small time, no, 17 watt hours, because 3 zeros and 1 kilo will be cancelled. Okay. Sir, if you take this here, assume that you are getting some x value. We are not interested in that. Sir, if I take EM minus ET like this, are we getting the correct value or not? Try to respond. I'll watch your answers. Try to respond. Here, if you are taking this value directly, AM minus AT by AT into 100, okay. But is it the answer he is asking? No. He is asking the error at which load? Half a load. That's why you must be very much careful in mentioning that energy true at half a load, energy measured at half a load, you need to calculate. Sir, energy true half a load means, have you taken full load or half a load here? Amperes he has given. 5 amperes is its rated current. Load current means automatically full load only we have taken. But we need to take which value? We need to take half a load means automatically we need to take, what is it? 5 by 2 here. So therefore, this is general mistake done by the people. You need to consider, I am using some other color for clarity purpose, 2.5. Then you will be getting the proper value. Okay, right. Now the point here is, sir, if you are taking this, right, you will be getting approximately 17.72 into the kilo and milli will be cancelled. So simply watt hours will be there. This is what the value. Now check it here. Sir, measured value, true value. But now the people's doubt is, sir, if the load is half calculation, we have replaced 5 with 2.5. Sir, what should be the modification done here? What modification should be done here? Means be careful. Here we made it to half. People are blindly making this to half. Is it? No. Go back to the question and see once. Here, whatever the 34 revolutions we are taking, that is at which load? Half a load only. At this load, they tested 34 revolutions, means we are having whatever the result we are having here, that is at half a load only. That's why no modification. But in this, In the place of 5 full load, half load 2.5 must be taken. Now, if you understand these concepts, so normal formula. What is that? Percentage error is equal to AM minus 80 by 80 into 100. AM minus 80 by 80 into 100. What is this? Kindly concentrate. AM 17 minus 80 17.72 by 80 17.72 into 100. Sir, small value minus large. Yes, minus. If you simplify this approximately minus 4%, you calculate 4 point something will be there, approximately 4. But in the options, in the examination, if multiple choice question is there, minus 4 will not be given. What they give, simply 4%, comma, slow will be given. Sir, what does it mean? What does it mean? Very simple. Sir, measured value is less than the true value. Sir, shown value is less than the true value means the disk is rotating with less speed. Or obviously, meter reading is less means the rotational, what is that? Disk speed is also less only. That's why either they mention with negative sign, correct, or they remove the negative sign, they mention the nature as slow, means energy meter is running slowly compared to what we require. That is what the point. Clear? Let us see one more question. AC voltmeter shown in the figure uses a PMMC instrument having an internal resistance of 50 ohm. What is the device given? PMMC instrument is given. Internal resistance is 50 ohm and DC current of 1 milliampere FSV, full scale deflection is given. Sir, the value of the multiplier resistance RS, the value of the multiplier resistance RS to obtain full scale meter deflection with 10 volts AC RMS, 10 volts AC RMS applied to the input terminals is. Sir, this is the question related to what is that? Diode type, rectifier type of instrument. Now the question is, sir, this is the rectifier type circuit he has given supportingly because shown in figure. Yes, this is the figure. What is the type of device? PMMC device. Okay. What he is asking, this value of RS is dash for getting the full scale deflection. In order to get the full scale deflection, what is the value he is asking? Now let us see. Here, is it full wave bridge or full bridge rectifier or half bridge rectifier? Sir, 4 diodes, automatically full bridge rectifier. Simply full bridge rectifier formula, if right, thing will be done. Very simple. Sir, here, what is the general formula? These are the options. Let us verify. Here, general formula of current. What is the current formula? I is equal to V by R total. I is equal to V by total resistance. Now, sir, which type of meter? PMMC type. PMMC means DC or AC. DC means average we are getting. So therefore PMMC reads average. How much current? 1 milli. So therefore I average he is giving indirectly 1 milliampere. So therefore here I average formula will be V average like this. Okay. Now, sir, as it is full bridge rectifier, what is V average formula? What is V average formula? In terms of RMS. In terms of RMS means RMS to average. RMS to average link is with form factor. If you use that, you will be getting 0.9 times of VRMS. 0.9 times of VRMS. Okay. Sir, what is the total resistance? RS plus diode resistances plus meter resistance. But if you observe the data clearly, do we have any comment related to the diode resistance? Not given. So simply assume that ideal. So 0. So therefore, formula I am writing RS plus 2 times of diode resistance plus meter resistance. Sir, why 2 RD? Everyone knows that full bridge rectifier, how many diodes will be there in the corresponding path? Obviously, 2 diodes in the path every time. So 2. But as he has not given any data, this must be taken as 0. Obviously, this must be taken as 0. Now, all other values are there except RS. So, therefore, what is I average? 1 milliampere, because full scale current related to PMMC is average only. So, therefore, 1 into 10 power minus 3 is equal to 0.9 into, what is VRMS? VRMS is 10 volt. 10 by RS plus. What is the meter resistance he has given? 50. He has given meter resistance as 50. If you simplify this, you are going to get the corresponding value. What is that? Very simple calculation. 1 into 10 power minus 3, 0.9 into 10. So 9 by RS plus 50. So therefore, RS plus 50 is equal to, it is coming over here means 9,000. Okay. So therefore, RS is equal to, what is the value? 8,950 ohm. So therefore, what we can say? 8.95 kilo ohm. This is related to electronic measurement type rectifier circuit notation. Let us verify the options. Yes, 9, 8.95, 9.05 and 6.31 means obviously 8.95 is the answer. Clear? Right. Okay. Now, next question. If a voltage of 0.6972 volt is being measured by a digital voltmeter, okay, then which of the following statement is true? This is related to electronic measurement in the digital voltmeter concept. Now, what will the option know? In this question is not asked. 4 options are given. Which option is correct? In this model, all varieties of concepts will be covered. Simple, direct, technique also I am going to give you. Now, see, these are the options. The voltmeter will display some number on 1 volt range. Which range? 1 volt range. The voltmeter will display some number on 10 volt range. And the voltmeter will display some number on 1 volt range. Means in the statements, what he has given? 1 volt range some data, 10 volts range some data, which is correct. He is asking last option, both A and B also given. But in order to answer this, direct method, simple technique. Sir, by a digital voltmeter he is using okay. But what is this? 1, 2, 3, 4, 5. Nothing but 5 digits are available in the corresponding circuit. Okay, now, sir, what is 1 volt display and what is correspondingly, right, 10 volts display, etc. We need to concentrate properly. What is 1 volt range and what is 10 volt range? Be clear. Sir, in the solution point of view, kindly concentrate. Here, first part, I am taking on 1 volt range. On 1 volt range, direct point, directly answer you can write. How many digits are there? What is it? Totally 1, 2, 3, 4, 5, like that it is given. Sir, 1 volt range, what will be the corresponding value display? So automatically 1 volt range means in the given data, automatically what will be the logic here? What will be the corresponding value here? Simply, sir, 1 volt display means where will be the decimal point here, right? Where the decimal point, this is first digit, second digit, third digit, fourth digit. This is generally of 4.5 digit type of meter we can say. So therefore, automatically, if the display is like this, 5 digits are there for example. Now on 1 volt range, where will be the decimal point here? Means here the decimal point will be there. What is that? It is 4.5 digit. Actually it is not given. It is missed actually 4.5 digit number only. So therefore, What is the value now? 1 volt range means decimal point will be here, and second one on 10 volt range on 10 volt range means direct step we can save lot of time. So 10 volt range means the decimal point will be here. What is it? This is 1 volt decimal point, 1 volt range, 10 volt range, 100 volt range, 1000 volt range. But actually it is missed in this typing by a 4.5 digit. It is there, actually it is missed. Okay, now what is the voltmeter will display which number? So 0.6972. Yes, perfectly fit in this. 0.6972. Yes, this is the corresponding display. Clear? And so 10 volt range. Sir, from the decimal point you write the number. What is that? Here 697. So after the decimal 6 is there, 9 and 7. So other numbers directly. This is the shortcut technique. Directly you can answer. But for this you need to have the basic point, like if you keep the decimal point here 1 volt range. See here 10 volt range, 100 volt range, 1000 volt range, etc. That's why for revision purpose I am giving that 4.5 device. In the question it is there here, don't worry. 4.5 digit device like this. I am giving the total explanation here. Here, this is 1 volt range. This is 10 volt range decimal point. This is 100 volt range decimal point. This is 1000 volt range decimal point. Okay, so therefore, if the 1 volt range is there, this is the decimal point position. In that way, concept also you know. So based on that, directly, sir, here 1 volt range and here 10 volt range means is based on that the number display will be there. Now verify that. Here, the voltmeter will display 0.6972 as it is on 1 volt range. Yes, 6972 correct. So therefore, first option is correct. Next, the voltmeter will display 0.697 on 6 volt range. What does it mean actually? Here, after the decimal 0.697. Yes, obviously, after the decimal 0.697. Actually, meaning is 00, but he is giving only 4-digit number. Otherwise, you can take like this. It will be given, no need to worry. So therefore, it is also correct. The voltmeter will display 0.697 on 1 volt range. Sir, on 1 volt range, is it possible? This number will not be missed. So therefore, this value is wrong. Sir, AB correct means, so final answer will be option D. Now I am erasing these two. Clear? This is related to correspond. Yes, many people gave the answer. Rahul Jaiswal. Yes, both A and B correct, sir. Correct. Very good, very good. Clear? Right. So answer is this. Right. Let us take one more question. Here, this is very popular model here. From the digital voltmeter, if 2 marks model question is there, mostly this model is possible. Mostly this model is possible. That a very popular one. What is that? A 3.5 digit multimeter. What is the point here? 3.5 digit multimeter. Right? Has an accuracy specification of 0.5% of reading plus 5 counts. The value of an unknown resistance is read as 50 ohm on the 200 ohm scale of the meter. Okay, so full scale value of the device is 200 ohm. The value of the resistance is, what is this resistance he is asking? Some value corresponding error. So indirectly, resistance value 50, okay, true value. In all the options that is maintained. What we need to find out? Corresponding error we need to find out. What is that? That we are going to see. But here also I am giving the point before starting. Most of the chances are there to get wrong answer for this model also. That wrong answer may be there in the options. Chance is there because negative marking. Be careful. I am keeping the star mark here. This is very popular model. Values will be changed, but model will be same. What is it? Let us see now. So first of all, here 3.5 device. 3.5 device. Sir, in the 3.5 device, in the resolution calculation, what is the value of n? 3. So n value is 3. This is what the main concept. N value is 3. Sir, what is the extension factor in this? Extension factor is 2 because 3.5 digit, everyone knows that, but extension factor is 2. So therefore, yes, okay, I'll write that later. Extension factor is 2. Okay. Now, 0.5% of reading, error is given as 0.5% of reading plus means 2 errors are given. What is that? 5 counts. So 5 counts related error is there. 5 counts related error. Okay. Sir, the resistance value 50, already we know the concept. Whenever the data is given like this, we need to treat that as a true value whenever it is necessary based on the given context. So therefore, true value, what is it? 50 ohm. True value is 50 ohm. What is the full scale value? 200. Yes, full scale value is 200 ohm. In this also, where we do the mistake in general, yes, I am going to give that. After that, I will correct your mistake. Be clear. Sir, let us find out the first error. 0.5% of reading. So, I am taking first error. 0.5% of reading. Okay. Sir, what is 0.5%? Simply we can write 0.5 by 100 into. What is the reading, guys? Reading is given as 50. Reading true value based on the context you have to consider. So therefore, here reading value 50. So therefore, substitute 50 ohm. So what will be the value? 50 by 100 to 0.5 by 2. So therefore, 0.25 ohm. This is one part of the error because he has given 2 errors. 0.5% of reading plus something is given. Yes, answer is 0.25. Okay, 0.25 ohm. But very important point, concentrate. Sir, in this, what is the meaning of count? While we were seeing the corresponding theory in this, you know that generally, what is it? Count means, what is it? Resolution value, because smallest measurable input changes resolution. In the digital voltmeter, generally one count will be, or one step we can say in the common language. One step is nothing but, one count nothing but resolution. Therefore, in order to get the 5 counts related error, 5 counts related error, what we need to have? One count value first. If we have one count value multiplied by 5 counts, in order to get one count value, what we have to do? We need to find out the resolution. Here problem is here. Concentrate. Sir, resolution formula. What is general formula? 1 by 10 power n into scale range. Right. What is general popular mistake with the people is this only. 1 by, as it is 3.5, n will be 3 into. The problem here is, sir, full scale value 200. By mistake, many people are taking this as 200. But if you take like this, definitely answer will be there. Right? That answer, yes, most of the cases option, in the options, it might be there. That's why. Is it correct or wrong means, be clear guys. Here, sir, full scale value is given with 200. Number means, is it the value after extension or before extension? This is after extension. Because 200 or 20 or 2000, for example, in that way, automatically extended. That's why be clear guys. If this is extended, given as extended, what you have to take here? In the formula, you need to take compulsory into 2. Because after extension range is given means extended counts only we have to take, and the 2 I am writing extended scale range. Now matching extended counts, extended scale range. Now this 200 is extended only, but we need to write 2 here. Very, very important point. You know the concept of this one. Okay, now, sir, 200 by 2000, you will be having 0.1, right? What is this 0.1? Of course, resistance 0.1 ohm. This is the resolution. This is the resolution. What is it? Resolution R. Okay. Sir, this resolution itself indicates one count value. One count value. Okay. Therefore, if this is equal to 1 count, therefore 5 counts is equal to, therefore 5 counts is equal to into 5. So simply 0.1 into 5. What is the value, guys? 0.5. Of course, resistance value ohm. Now verify. Sir, 0.5% of reading plus 5 counts error is there. Yes. Here 0.5% of reading error is 0.25. 5 counts error is 0.5. Determine the total resistance? Yes. So therefore, what we can say? Therefore, total resistance. Therefore, total resistance. Right? Nothing but. We can say total error in the resistance also we can write. Therefore, total error. Total error is 0.25 one error plus 0.5 one more error. Therefore, it will be equal to 0.75 ohm. This is what the final answer. Right? After that, he is asking this only, but he is representing the total value. Therefore, the resistance is equal to, resistance R is equal to 50 ohm plus or minus, error is how much? 0.75, so many ohms. This is the final representation of the resistance. Clear, guys? In this, where you need to concentrate? At this step, you need to concentrate. Extended range if you are taking, extended counts we have to take. Suppose people are asking this, sir, if I want to take 10 power 3 here, you have to take 100 only. 2 into 100, 2 is the extension. 100 is the normal range. That's why extended to extended, normal to normal. This is the logic generally we use in the corresponding digital voltmeter. Clear, guys? Very good. Rahul Jaiswal, yes, extended range, sir. Very good, very good, very good. Already given the answer. Very nice. What is the option here? 50 plus or minus 0.75. Right? 50 plus or minus 0.75 is, yes, which option? Option C. Very good. Clear? Right. Let us take one more question. Right. Here. This is a CRT has an anode voltage of, a CRT has an anode voltage of 2 kilovolt. This is the question related to CRO concept. Right? It has the anode voltage of 2 kilovolt. It is also very popular in the GATE exam or in the other exam, which ESC also. Yes, very popular question. And the parallel deflecting plates are 2 centimeter long and 5 mm apart. 5 mm apart. What is the length of the parallel plates? 2 centimeter. What is the distance between, separation between those two plates? 5 mm. The screen is 30 centimeter away from the center of the plates. Means plates to screen distance is how much? 30 centimeter. Now, the input voltage is applied to the deflecting plates through amplifier having a overall gain of 50. So, amplifier gain is given as 50. Very important. The input voltage required to deflect the beam, input voltage required to deflect the beam through the 3 centimeter will be? Through the 3 centimeter will be. He is asking that. But if you see the options, 1 volt, 100 volt, 2 volt, 50. Suppose if you are observing the options without completing the solution, there is a chance of selecting the wrong option. That is what the problem with these type of questions. Means we are doing something, right? After some calculation, we get X volt. If you see the options, that value will be there. Immediately we'll tick it. But is it? No. That's why try to understand each and every step. Okay. Now let us write the given data. Right. What is the given data? Anode voltage of 2 kilovolt. Anode voltage. Nothing but final anode voltage only we say VA 2 kilovolt. Okay. Next. The parallel deflecting plates length 2 centimeter. So generally length of the plates I am taking as capital L, for example. What is it? 2 centimeter. But here problem is all must be converted into meters, then simplification will be easy. That is what the point. 2 centimeter, convert that into meters and keep it with you. And here both the plates are separated, means 5 mm apart, means the parallel plates will be like this. Between these two, the gap separation is, what is that? 5 mm. So therefore, this I am taking as, what is that? Small and nothing but separation, yes I am taking. Separation, yes. What is that? 5 mm. 5 mm. Clear? Right. After that, the screen is 30 centimeter away from the center, means from the plate to screen 30 centimeter is there. What is that? I am keeping that as capital D. Capital D, for example. What is that? 30 centimeter. Clear? After that, sir, L is there, D is there, S is there, and VA is also given. But one more data is given that this entire system is operated with or input given with amplifier with a gain of 50. So therefore, let us write that also. Gain of amplifier is 50. Gain of amplifier is 50. Okay. Now, what he is asking? Voltage applied, input voltage required to the beam through the 3 centimeter deflection. So therefore, deflection he is expecting for 3 centimeter, then input voltage is dash. This is what the question. Now, sir, in this type of questions, we know the formula vertical deflection sensitivity. Vertical deflection sensitivity. Formula we know. Let us find out that first. What is that? Here, vertical deflection sensitivity, I am writing as SV. Only the thing is, you must be able to recollect the formula. Vertical, what is that? Deflection sensitivity. What is the formula? LD by 2SVA. This is sensitivity, but this is separation. Don't get confused. Okay? Sir, what is L? What is D? What is S? VA? Everything is given. Everything is given. Okay, so simply substitute 2 centimeters, nothing but 0.02 meters into distance D 30 centimeter, so simply 0.3 meter. I am converting everything into meter, and 2 into, yes, what is the separation? 5 mm, nothing but 0.005 into, what is that? 2000, 2 kilovolt. So 2000. If you simplify this, you will get sensitivity. Okay. But what is sensitivity formula? What is that? Vertical deflection sensitivity. This is, what is that? Vertical deflection sensitivity. Deflection sensitivity. What is its formula? Simply, deflection sensitivity means, what is that? Deflection by voltage required, amount of voltage we require. So simply, voltage input we can say. Simple formula I'm writing. Voltage input. Vertical deflection sensitivity means amount of deflection produced per the input voltage, unit input voltage, etc. Now, from this, sir, deflection, how much he is asking? 3 centimeter deflection he is asking. So, therefore, in the place of SV, what we can write? Therefore, here, 3 centimeter means 0.03 by VI is equal to total value 0.02 into 0.3 by 2 into 0.005 into 2000. Sir, if you simplify this, you are going to have the voltage input. Just simplify, you are going to have the voltage input. Right? Now, the question is, kindly give me the answer. VI will be 100 volt. VI will be 100 volt. The first mistake what we do here is, the moment input voltage is, what is that? 100 volt. People are observing the options. Sir, 100, sir. No. What he is asking? Input voltage given to the entire system. But what is this? This is the input voltage related to the after amplifier notation. But amplifier gain is there? No. That's why this is voltage for the corresponding plate structure. But for the entire input means before the amplifier. Therefore, what is it here? Amplifier gain. Amplifier gain is given as 50. Amplifier gain is given as 50. So therefore, amplifier output will be this voltage. Amplifier output voltage. He is asking main input. That is what very important point. So therefore, what is the gain formula? Simply output of the amplifier by input of the amplifier. That's why even though this is VI, it is amplifier output given to the deflecting plates as the input. But he is asking main input. So that's why 50 is equal to what we can write? 100 by V main input or total input voltage. So therefore, what we can write? V total input of the system is how much? 2 ohms. Suppose if he has not mentioned anything regarding amplifier, directly signal is given, this is correct only. Entire setup is getting the input voltage, getting the voltage with the amplifier gain, very important. We call this as input only, but this is output of the amplifier. But he is asking main input. So answer will be 2 volts. Now check it. Which option? Yes, 100 is there, 2 is there, but correct answer is 2 volts only. Clear, guys? Right. Yeah, one student gave that. Yes, 2 volts. But 100 is there, guys. Definitely to confuse you. Whatever we feel like wrong answer is the correct answer, that answer will be given in the options. So be careful. Right? Now let us take one more question. Of a CRO is equivalent to a 1 mega ohm resistance in parallel with a 90 picofarad capacitance. Nothing but this is the question related to. This is the question related to which value? CRO probe concept value. So CRO probe value. Okay. Now, if it is used with the compensation, right? It is used with compensated 10:1 attenuation. Yes, attenuation probe. Be careful. This is related to CRO probe. Now let us see the data. Right? This is parallel combination of 1 mega 90 picofarad capacitance. Okay. Probe value given. The effective input capacitance at the probe tip is. So what he is asking? Total capacitance or effective capacitance at the tip. Effective capacitance at the tip means probe capacitance along with that input capacitance of the CRO combinedly effective capacitance combination, not plus but combination. What is the value? Now options are given like 9 pico, 90 pico, 10 pico or 45 pico, etc. And after taking the entire CRO probe, what is it? Equivalent circuit diagram, simplification, we know that the mathematical formula of C effective capacitance value is dash. Remember, the effective capacitance value is input, what is it? Whatever the capacitance is there here, input capacitance by probe number. What is the probe number? 10. So therefore, Ci by n we can say Ci by 10. Direct answer. Question is very lengthy, but answer is only one step. That is what? Here. Is the effective capacitance? C effective is equal to Ci by 10. Sir, why 10? Why 10? The point is 10 to 1 probe is there. So automatically n value is 10. So therefore n is 10. I have substituted. Direct answer. What is Ci? Input capacitance 90 picofarad. 90 picofarad by 10. So automatically 9 picofarad. 9 picofarad. Direct answer. Okay. Now see that. 9 is there, 90 is there, 10 is there, and 45. But be clear, in this entire thing, what people are getting confused, sir, people are thinking like, sir, Ci by 10 minus 1, so 9, 90 by 9, 10. That is also getting confused. Yes, 10 will be there. That's why if you get confused with the small formula related thing, definitely that formula related value will be there in the options compulsory. So that's why answer is Ci by n only. Means this is n value is 10, not n minus 1. This is n only. N minus 1 is for other values like Rp, Ri, Cp, Ci relation. But here C effective and Ci relation. So automatically Ci by n formula. Input capacitance by 10. Clear? Right, let us take one more question. Yeah, Rahul Jaiswal, he is sharing his experience. Sir, I got 100 volts, but unfortunately, it gave me negative mark. Definitely, right? Definitely. In the earlier question, sir, 100, he has ticked for 100, but answer is 2. 100, you are choosing means negative mark. Very good, very good. Try to overcome the problems like this. Yes, right. Next question. The Wien's bridge shown in the figure is balanced at a frequency of direct question, but remember the formula. Only the problem is calculation. What is that? Check it here. This is the bridge. Sir, is it Wien's bridge or not? Check it. RC parallel, RC series, 2 resistances. Automatically, we can say this is which bridge? Wien's bridge only. Obviously, Wien's bridge. Now, in the Wien's bridge, what is the frequency under balancing condition? Balanced at a frequency of, what is the frequency under balancing condition? Very, very important formula. 1 by 2 pi R1 R2 into C1 C2. Root, 1 by root will be there, etc. Now, answers also given. Direct question here, these type of questions also may be expected as 1 mark questions, direct answers. Okay. Now let us write. In the Wien's bridge, what is the formula? Is equal to 1 by 2 pi, right? Generally every student knows that, sir, 1 by 2 pi RC, no? Yes, 1 by 2 pi RC, but this is not the direct formula. Actually speaking, root of R1, R2, C1, C2 will be there. But after that assumption, if R1 equal to R2, C1 equal to C2, then this value will be there. Okay, let us verify. Sir, R1 10 kilo, R2 4.7 kilo, not same. So therefore, we cannot use this formula directly. So that's why basic formula. What is that? Root of R1, R2, C1, C2. R1, R2, C1, C2. Sir, what is the corresponding thing? 1 by, right? 2 pi. Only the thing is, I told you, no, calculation part. If you are able to recollect the formula, just calculation part. What is that? Sir, R1. In this, you take this as R1, this as C1, this as R2, this as C2. Nothing but RC parallel, RC series, R1, R2. What is it? C1, C2 will be there. So substitute that. R1 10 kilo, R2 4.7 kilo. 10 kilo into 4.7 kilo into C1, C2. C1 10 nano, 5 nano. 10 nano into 5 nano. Right. Kindly calculate direct calculation. That calculation you will be getting in terms of hertz. So direct answer. These type of questions are also possible as 1 mark model. Definitely as 1 mark model, these type of questions chance is there. Calculate everyone. I'll give the value, don't worry, just calculate it. R1, R2, C1, C2, 10 nano and 5 nano is there. Simplify. Okay, try to give the answers. Right. If you see that, you will be getting approximately 3.28 kilohertz. Approximately you will be getting 3.28 kilohertz. Right, that is what? Option C. Just verify. Always, whenever I am giving the values directly, you need to calculate, you need to verify your value with my value. Because I am not wasting the time by calculating the things. I am giving the value directly after explaining the complete concept. Clear? Right. And one student is asking that, sir, what is the general weightage for electrical, etc.? See, electrical people generally the weightage will be 3 to 4 marks or around 4 marks. But sometimes it may be 3 marks, sometimes 2 marks, last year only 1 mark. May be varied. But instrumentation people 10 to 12 marks will be there. That's why electrical people 3, 4, 1, 2 like that will be varied. Instrumentation also will be varied like 9, 10, 11, 12, etc. This is a general weightage. As people are requesting, I am giving this. Okay. Ayush Mittal and Rahul. Okay, 3.2. Yes, 3.2. 3.28 or 3.2. Got it. Very good. Very good. Now, let us come back. Next question. 3-phase 500 volt motor load has a power factor of 0.4. Conceptual and simple small numerical will be there. Sir, what is the voltage here? 500 volt. Power factor of 0.4. 2 wattmeters connected to measure, of course, 2 wattmeter method. They show the input to be 30 kilowatt. Very, very important point. Sir, input power means total power is P1 plus P2. 2 wattmeter means W1 plus W2 is 30 kilowatt. Okay. Find the reading each instrument. Find the reading of each instrument. That's what the data. And options are given. Yes. This answer I'm giving directly. No options. Answer I'm giving. Let us verify. What is it? You know, in the given data, which is available to us, power factor is available. Okay. Power factor. Cos phi is equal to 0.4. Cos phi is equal to 0.4. And they show the input to be 30 kilowatt. What is that? W1 plus W2 is 30 kilowatt. 30 kilowatt. Okay. W1, W2, 30 kilowatt. Okay. Now the point is, find the reading of each instrument. Very important. Sir, he is asking W1 value as well as W2 value. If you understand the logical key point, simple mathematics only. Sir, only power factor is there. Of course, voltage is given. Right now, sir, total power is there, power factor value is there. But sir, how to proceed? How to proceed, sir, means very, very simple. Yeah. What is the power factor formula? Cos phi is equal to, everyone knows universal formula. Cos phi is equal to cos of tan inverse root 3 W1 minus W2 by W1 plus W2. W1 minus W2 by W1 plus W2. Sir, in this entire formula, if you observe keenly, power factor is given 0.4. You can substitute here. W1 plus W2 also given total power 30 kilowatt. Can you get W1 minus W2? That is what the logic. People are getting confused without starting. Sir, these two are there. How can we get W1, W2? People are getting confused. That's why if you are able to recollect the formula, cos phi, cos of something, tan inverse, etc. In this entire equation, what values are given? Cos phi and W1 plus W2 are given. Clear? Sir, W1 minus W2 is unknown. Get it. Okay. After getting that, be clear. He is asking that reading of each wattmeter. Reading of each wattmeter he is asking. What is it? Let us see. Here, if you simplify this, you will be getting, therefore, W1 minus W2 as, you will be getting approximately, right? Here, you will be getting 39.7 kilowatt. 39.7 kilowatt. Sir, after this, how to proceed? Don't get confused. Simple mathematics. Very, very, very simple mathematics. First one, W1 plus W2 is equal to 30 kilowatt and W1 minus W2 is equal to 39.7 kilowatt. Again, I'm giving one more conceptual point. Sir, answer is wrong, sir. Procedure is wrong, sir. People are saying like this. Why? Sir, if you are adding the 2 wattmeter readings, 30 is there. If you are subtracting the 2 wattmeter readings more than 30, sir, something is went wrong, sir. No, something went wrong. That is not at all correct. Everything is correct only. How? Be clear. Go to the question. If you observe this power factor value clearly, you need to recollect the corresponding concept. What is that? Power factor is less than. Power factor is less than 0.5. If the power factor is less than 0.5, one of the wattmeters reading must be negative. That is the standard point. That's why, what is this? Just I'm giving the hint here. What is that? As the power factor, as cos phi is less than 0.5, you must be able to recollect this point compulsory. As the power factor is less than 0.5, that is 0.4, right? 1 wattmeter reading, 1 wattmeter reading is negative. 1 wattmeter reading is negative. If you understand that, if you are able to recollect that point without any confusion, you can proceed. But after getting this only, most of the people are sending this solution. Sir, W1 minus W2, right? It is more than this one. What is the mistake, sir? Nothing, no need to worry. Now your duty is to simplify these 2 equations and W1 value, W2 value. Simple mathematics. Cancel these 2, W1 equal to, add these 2 and get the value. That's it. Definitely one will be positive, other will be negative. That is what the answer. Clear everyone? What is the logic here? Power factor is less than 0.5. Automatically one of the wattmeters reading will be negative. Yes. Based on that we can write it. Negative of minus of negative. So automatically positive. No, value will be increased automatically. That's what the point. Okay. If you simplify this, I'm giving the value here 34.85 kilowatt and minus 4.85 kilowatt. These two are the final answers. I am repeating, verify your values with my values after the calculation. Very good, very good. So yes sir, if power factor is less than 0.5, then one of the wattmeter gives negative. Very good. You must be able to recollect that. That is the reason why we are having this session, to revise the subject also. Expected questions will be practiced. Total concept also will be revised simply. Clear? Right, let us take one more question. Wattmeter has a current coil of 0.03 ohm resistance and pressure coil of 6000 ohm resistance. The load takes 20 amperes at a voltage of 220 volt and 0.6 power factor. Right? Be clear? Here, this is load takes 20 ampere at a voltage of 220 volt, 0.6 power factor. But be clear, what load current would give equal error with the two connections? Nothing but what is the error in MC short connection, LC short connection? We have seen one question earlier. But in this MC short and LC short connections, in both the connections, error must be same. That's what he is asking. What load current, right? What load current would give equal errors in two connections? Very, very important point is this. Means he is asking simply the condition for same error in both the cases. But he is asking current value. I think everyone able to recollect that formula. Okay, let us see options later. Here, what is the formula? Here, the condition for same error. The condition for same error in both connections. The condition for same error in both connections. What is the condition? Load resistance RL is equal to root of RCC into RPC. This is the universal formula. You must be able to recollect. Okay. Now, what is RL? VL by IL, right? Root of RCC into RPC. That's it. VL. In the given question, what is VL? 220 volt. Okay. But IL is given 20. Okay. That is normal. How much load current is required to get the same error? Means it may not be given the same error. That's why what is that current he is asking? 220 volt. 220 volt by IL is equal to root of, what is RCC and RPC? RCC 0.03, RPC 6000. 0.03 into RPC is 6000. Simple. Therefore, IL is equal to, calculated, IL is equal to, what is the value? If you simplify this, you are going to get approximately 16.4 amperes. Kindly verify this. Generally, while in the classroom practicing, right, generally we calculate what is that RCC value or RPC value to get the same error like that. But here, twisting, reverse question. RCC is given, RPC is given, and IL we need to calculate what can be the current to give same error. Of course, load is taking 20 normally, but if that load takes the 16.4 amperes, then we can say error in MC connection and error in LC connection, both will be same. That is what the actual point here, right? And here, this is what the answer, 16.4. Here guys, right, let us take one more question. Right, now the question is, very simple question is there. Right. Meters which are connected to measure total power. Very, very, very important conceptual question. Very, very small question, conceptual question, without writing anything, without doing anything, directly you can answer. What is that? 2 wattmeters which are connected to measure the total power on a 3-phase system supplying a balanced load, right? Reads here 10.5 kilowatt minus 2.5 kilowatt respectively, the total power and the power factor respectively dash. Very, very important. Sir, very simple. W1 is there, W2 is there. What is the total power? W1 plus W2. 10.5 plus minus 2.5. Directly answer is 8 kilo. But sir, don't take the pen and paper to calculate cos phi, so and so, etc. Not required. Logic is, sir, one of the wattmeter's reading is negative. At which condition? Power factor is less than 0.5. Let us see the options. Sir, 10.5 minus 2.5, 8 kilo means A option is wrong, B option is wrong. But in the C option, 8 kilo is there, but power factor is 0.52. But our condition is power factor must be less than 0.5. Therefore, without writing anything, directly we can choose the option, that is 8 kilowatt and 0.334 less than. Even though you calculate by using this cos of tan inverse root 3 W1 minus W2 by W1 plus W2, you are going to have the same answer. You can verify. But directly, looking lengthy, but 1 mark model, directly you can answer. So this is what the total discussion regarding all types of questions related to measurements. Clear? Thank you.